How do you delete a node from a linked list when you only know how far it sits from the end, not from the front? Today let's look at a classic problem. Remove the nth node from the end of a list. Opening, we are given the head of a singly linked list and an integer n. The task is to remove the nth node from the end of the list, then hand back the new head. As an example, if the list holds the values 1, 2, 3, 4, 5, and n equals 2, the node with value 4 is the second node from the end, so the result should be 1, 2, 3, 5. Naive approach. A straightforward way is to make two passes over the list. First, walk from the head to find the total length. Then walk a second time to the node at position length minus n and remove it. This runs in linear time, but it scans the list twice, and we would like to do it in a single pass. Core idea. The elegant solution uses two pointers called fast and slow, together with a dummy head node placed before the real head. First, advance the fast pointer n plus 1 steps ahead of the slow pointer. Then move both pointers one step at a time until the fast pointer reaches the end of the list. At that moment, the slow pointer sits exactly one node before the target, so we can remove the target in a single pass. Key details. Why n plus 1 steps? Because we want the slow pointer to stop one node before the target, not on the target itself. The dummy head makes this work even when we need to delete the original head node, since the slow pointer can rest on the dummy right before the head. Finally, we remove the target by making the slow pointer skip over it, pointing to the node after the target instead. Walkthrough. Let's trace the first example. We are given the list holding 1, 2, 3, 4, 5, and n equals 2. Our goal is to remove the second node from the end, which is the node holding value 4. First, we create a dummy head node with value 0 and link it to the real head, which holds value 1. This gives us a safe place to stand in front of the list. Next, we place the fast pointer on the dummy node. It will run ahead to build the lead. We also place the slow pointer on the dummy node. Both pointers now start from the same place, the dummy. The fast pointer takes its first step forward, moving from the dummy to the node holding value 1. It needs 3 steps in total, since n plus 1 equals 3. The fast pointer takes its second step forward, moving to the node holding value 2. The lead is growing. The fast pointer takes its third step forward, moving to the node holding value 3. It is now 3 nodes ahead of the slow pointer, which still rests on the dummy. Now, the fast and slow pointers move together. In the first joint step, the fast pointer advances one more node, landing on the node holding value 4. Then, the slow pointer advances one node, landing on the node holding value 1. The gap between fast and slow stays at 3 nodes. In the second joint step, the fast pointer advances one node, landing on the node holding value 5, the last node in the list. Then the slow pointer advances one node, landing on the node holding value 2. The gap of 3 nodes is preserved. In the third joint step, the fast pointer advances past the last node and now points to nothing, meaning it has left the list. Then the slow pointer advances one node, landing on the node holding value 3. Since the fast pointer has fallen off the end, the slow pointer is now exactly one node before the target. The node to delete is the one right after the slow pointer, which is the node holding value 4. That is the second node from the end, exactly the target we wanted. We unlink that node by making the slow pointer skip over it, pointing instead to the node after the target, which holds value 5. The node holding value 4 is now cut off from the list and removed. Finally, we hand back the node after the dummy, which points to the node holding value 1. The resulting list is 1, 2, 3, 5, with the node holding value 4 gone. Complexity and summary. The algorithm visits each node at most once, so the running time is linear in the length of the list, that is, big O of L. It only uses a few extra pointers, so the extra space is constant, big O of 1. The key trick is the fast and slow pointer pair plus a dummy head, which lets us remove the nth node from the end in a single pass. Thank you, and see you next time.